October 1942, the North Atlantic. Convoy HX-212 ploughed through 30-foot swells under slate-grey skies that promised nothing but misery. Among the 42 merchant vessels straining against the storm was the SS Robert E. Peary, fresh from the Kaiser shipyard in Richmond, California. She'd been at sea exactly 11 days. Her welded seams, untested by anything beyond the builder's dock, groaned against waves that had shattered ships with decades of service. On the bridge of U-boat U-432, Kapitan Lieutenant Hermann Eckart studied the convoy through his periscope. His executive officer, noting the boxy, ungainly silhouette of the Liberty ship, couldn't suppress a laugh. "Herr Callot, the Americans are sending us targets made of tin cans and prayers. That one looks like a floating shoebox." Eckart had seen the intelligence reports. The new American emergency freighters, built in sections by workers who'd never touched a ship before, welded together by housewives and farmers in shipyards that hadn't existed a year earlier. Design specifications stolen from an obsolete British tramp steamer. Propulsion systems so underpowered they could barely manage 11 knots in calm seas. The Kriegsmarine's assessment had been unanimous. Disposable junk. Targets so poorly constructed they'd probably sink themselves. "Mark her position," Eckart ordered, his smirk visible even in the submarine's dim lighting. "We'll put her down after the storm passes. 1 torpedo. She'll probably break in half from the shockwave alone." What Eckart didn't know, what none of the German naval command could have imagined, was that those floating shoeboxes would bury the Kriegsmarine under a tidal wave of steel. Within 3 years, Liberty ships would outnumber the entire German merchant fleet by a factor of 10. They would carry 75% of all cargo shipped overseas during the war. They would be built faster than U-boats could sink them, manufactured at a rate that would transform naval warfare from a contest of quality into an overwhelming demonstration of industrial supremacy. The Germans had laughed at the ugly American freighters in 1942. By 1945, they would be drowning in them. The Liberty ship's origin story began not with naval architects or maritime engineers, but with desperation. In 1940, Britain was being strangled. The U-boat campaign had sent 3 million tons of British shipping to the bottom. Merchant losses exceeded new construction by catastrophic margins. At the current rate, Britain would be forced to surrender by mid-1941, not through military defeat, but through simple starvation. The British merchant shipbuilding mission arrived in Washington in December 1940 with a radical proposal. They needed ships, lots of ships. Ships so simple they could be built by workers with no shipbuilding experience. Ships so cheap that losing half of them to U-boats would still represent a net gain. Ships that abandoned every principle of elegant naval architecture in favour of crude functionality. The design they brought was the Ocean class, itself based on a 1930s tramp steamer called the Dorrington Court. It was obsolete before the war started, slow, ungainly, inefficient. But it had one overwhelming advantage. It was simple. The entire ship could be broken down into prefabricated sections that could be manufactured anywhere and assembled rapidly. The US Maritime Commission, led by Rear Admiral Emery Land, looked at the British proposal with poorly concealed disgust. Admiral Land, a distinguished naval architect, called the design a dreadful-looking object. The American Society of Naval Architects examined the specifications and issued a scathing assessment. Underpowered engines that guaranteed sluggish performance, reciprocating steam engines instead of modern turbines, welded construction instead of traditional riveting, a technique distrusted by traditional shipbuilders who believed welded seams would crack under stress. Cargo holds so basic they lacked even basic ventilation systems. But President Roosevelt, understanding that perfection was the enemy of production, overruled the experts. America would build the British design, modified slightly and rechristened the EC2 SC1 type. The designation was bureaucratic and forgettable. The name that would become legendary came from Roosevelt himself, who declared these vessels would be Liberty ships, carrying the means of liberation to occupied Europe. The man tasked with the impossible job of building these ships had never constructed an ocean-going vessel in his life. Henry Kaiser was an industrialist, a dam builder, a man who'd made his fortune in concrete and highways. His experience with ships consisted of building concrete barges for aggregate transport. The established shipbuilding firms on the East Coast, with their century-old traditions and craft guild mentalities, openly mocked his appointment. Kaiser's response was pure American pragmatism. If the traditional shipyards couldn't build fast enough, he'd build new shipyards, and he'd staff them with workers who didn't know enough about shipbuilding to understand why his methods were supposedly impossible. The Richmond shipyard in California, Kaiser's first facility, was carved out of mudflats in 100 days. Where traditional shipyards built ships one at a time using skilled craftsmen who'd served years of apprenticeship, Kaiser would use assembly line principles lifted directly from automobile manufacturing. Ships would be built in prefabricated sections by workers performing a single task repeatedly until they achieved machine-like efficiency. The established maritime industry predicted catastrophic failure. Arthur Homer, president of the Bethlehem Steel Shipbuilding Division, publicly stated that Kaiser's welded ships would crack apart in heavy seas. The American Bureau of Shipping expressed grave concerns about structural integrity. Maritime unions warned that unskilled workers would produce dangerous vessels that would kill their crews. Construction of the first Liberty ship, the SS Patrick Henry, began in April 1941 at the Bethlehem Fairfield Shipyard in Baltimore. The initial construction time was 244 days, far slower than the British were sinking ships. Kaiser watched the traditional shipyard's pace with growing frustration. His Richmond facility came online in December 1941, just as Pearl Harbor transformed ship production from an important priority into an existential necessity. What happened next would rewrite every assumption about shipbuilding. Kaiser implemented a modular construction system that would have seemed insane to traditional naval architects. The ship's hull was divided into prefabricated sections, each built by different work crews in different parts of the yard. Bow sections, stern sections, midship sections, all constructed simultaneously and then lifted into place by massive cranes. The workforce was unprecedented in shipbuilding history. Richmond employed housewives who'd never worked outside the home, farmers from the Midwest Dust Bowl, teenagers barely out of high school. African Americans and women were hired in numbers inconceivable in the discriminatory shipbuilding industry. 1 in 4 workers at Kaiser's yards were women. They worked as welders, riveters, crane operators, and in virtually every skilled trade that had previously been male-only domains. Rosie the Riveter wasn't just propaganda. She was a welder named Rose Will Monroe, building Liberty ships at the Ford plant in Michigan. She was one of 200,000 women who would eventually work in American shipyards, performing jobs that industry experts had insisted required male strength and years of experience. The training program was equally revolutionary. Traditional shipyard apprenticeships took 4 years. Kaiser's welding school graduated workers in 4 weeks. The curriculum was brutally focused. You didn't learn the theory of metallurgy. You learned to make one specific weld over and over until you could do it blindfolded. Then you went into the yard and made that same weld 500 times a day. Joseph James, a welder who started at Richmond in February 1942, later recalled his training. They showed me how to strike an arc, how to control the bead, how to check penetration. That was it. 3 weeks of practice and I was on a hull section. I made the same vertical weld on bulkhead seams, 8 hours a day, 6 days a week. I got so good I could judge the quality by sound alone. After a month, I could outweld guys who'd been in the trade for 20 years, because I only had to be perfect at one thing. The speed of construction accelerated with terrifying momentum. By mid-1942, Kaiser's Richmond yard was completing Liberty ships in 60 days, then 40 days. In September 1942, the Richmond yard launched the SS Robert E. Peary in 4 days and 15 hours from keel laying to launch, a world record that stands to this day. The stunt was partly propaganda. The ship wasn't fully outfitted and required weeks of additional work, but it demonstrated the potential of American mass production. More importantly, the average construction time for a fully equipped Liberty ship fell to 42 days by 1943. Kaiser's 18 shipyards were launching 3 ships every 2 days. The New England Shipbuilding Corporation in South Portland, Maine, was completing a Liberty ship every 30 days. The Bethlehem Fairfield yard in Baltimore, which had taken 244 days for the first Liberty, was launching one every 25 days. The scale defied comprehension. At peak production in 1943, American shipyards completed a new Liberty ship every 8 hours. The hull sections were so standardized that components built in Pennsylvania could be shipped to California and fit perfectly into ships under construction 3,000 miles away. The supply chain reached into every corner of American industry. The boilers came from manufacturers in Ohio, the engines from shipyards in Pennsylvania, the propellers from foundries in Michigan, the steel plates from mills in Indiana, each one cut to exact specifications and numbered for assembly. Admiral Karl Dönitz, commanding the German U-boat fleet, watched these developments with growing alarm. His U-boats were sinking Allied ships at an impressive rate. In 1942, German submarines sank 64 Allied ships totaling 7.8 million tons. But intelligence reports from the United States described a construction program that seemed impossible. The Americans claimed they were building ships faster than Germany could sink them. Dönitz didn't believe it. No nation could build that fast. The reports had to be exaggerated, propaganda meant to boost Allied morale. He calculated that each U-boat needed to sink 600,000 tons of Allied shipping annually to win the Battle of the Atlantic. His fleet of operational boats fluctuated between 100 and 200 submarines. The mathematics seemed favourable. The Allies couldn't possibly replace losses on that scale. What Dönitz didn't factor into his calculations was the fundamental transformation of shipbuilding from a craft into an industrial process. A single Kaiser shipyard in Richmond employed 100,000 workers. The entire German submarine construction program employed approximately 100,000 workers total. Kaiser alone was building ships at a rate that exceeded the entire British merchant shipbuilding capacity. The first Liberty ships to face U-boat attack in significant numbers were the vessels of convoy SC-107 in November 1942. A wolf pack of 17 U-boats intercepted the convoy south of Greenland, sinking 15 ships over 5 days of sustained attacks. 8 of the lost vessels were Liberty ships. The German submariners filed action reports noting how easily the American freighters went down. 1 torpedo, sometimes 2, and they sank rapidly. The Kriegsmarine's assessment seemed confirmed. The Liberty ships were death traps. Poorly constructed, inadequately defended, they were easy kills. Admiral Dönitz predicted that the combination of heavy losses and low construction quality would force the Americans to abandon the program within a year. Instead, American production accelerated. For every Liberty ship sunk in November 1942, 3 were launched. The mathematics of attrition had reversed. The U-boats were no longer hunting faster than the Americans could build, they were falling behind. By the end of 1942, the grim calculus became apparent. Germany had sunk approximately 140 Liberty ships since the program began. American shipyards had launched 597. The disparity would only grow worse. But the Liberty ships had a more fundamental problem than production numbers. They were breaking apart. Not from U-boat torpedoes or storm damage, but spontaneously, catastrophically, for no apparent reason. In January 1943, the SS Schenectady, docked in calm waters in Portland, Oregon, suddenly cracked in half with a sound like a cannon shot. The entire midship section fractured completely, the hull split from deck to keel. The ship, which had been launched just 6 weeks earlier, broke into 2 pieces that slowly settled into the harbour. 3 days later, the SS Esso Manhattan, a tanker built using Liberty ship construction techniques, suffered a similar failure in New York Harbour. Then the SS Pontypridd broke in 2 while alongside a dock in Canada. Most catastrophically, the SS John P. Gaines broke apart in the Pacific, killing 10 crew members. The maritime industry's worst predictions seemed to be coming true. The welded construction that Kaiser had championed was fundamentally flawed. Ships were literally tearing themselves apart. The American Bureau of Shipping launched an urgent investigation. If Liberty ships continued failing at this rate, the entire emergency shipbuilding program would collapse. The investigation revealed a phenomenon that metallurgists had never encountered at this scale: brittle fracture in welded steel. Traditional riveted construction had natural crack stoppers. Each rivet hole interrupted the propagation of stress fractures. But welded construction created continuous seams. A crack starting at a single point could propagate through the entire hull structure without interruption. The problem was exacerbated by wartime steel production shortcuts. The steel used in Liberty ships had higher sulfur content than peacetime specifications allowed. In cold water, this steel became brittle, losing its ductility. Add stress concentrators, square hatch corners, sudden transitions in plate thickness, and you created fracture initiation points. The solution required fundamental design modifications. Engineers added riveted crack arresters at critical stress points. Hatch corners were redesigned with rounded fillies. Welding procedures were revised to reduce residual stresses. Steel specifications were tightened. Most importantly, welders received additional training and techniques to avoid creating stress concentrators. The modifications worked. Catastrophic hull failures dropped to near zero by mid-1943. The Liberty ships would prove remarkably durable in service, but the early failures had provided ammunition for German propaganda. Radio broadcasts from Berlin mocked the American ships that sank themselves, dubbing them Kaiser's coffins, and predicting wholesale destruction of convoys through structural failure rather than German action. The propaganda was premature. By late 1943, Liberty ships were crossing the Atlantic in massive convoys, and their true advantages were becoming apparent. The very characteristics that made them seem inferior as ships made them superior as tools of logistics. A Liberty ship could carry 10,800 deadweight tons of cargo. That's 440 Sherman tanks, or 2,140 jeeps, or 440 2.5-ton trucks, or enough ammunition to supply an entire infantry division for 6 months. The 5 cargo holds could accommodate virtually any military cargo. Locomotives were loaded whole. Aircraft were stowed partially assembled. Tanks drove directly into the holds via reinforced ramps. Loading times were dramatically faster than traditional cargo vessels. The ships had 11 cargo booms, their own cargo handling gear that eliminated dependence on port facilities. A Liberty ship could be completely loaded or unloaded in 48 hours by experienced stevedore crews. In combat zones with damaged port facilities, Liberty ships often unloaded themselves, their crew operating the cargo booms to transfer material directly to smaller craft or even to beaches. The operational tempo was relentless. A Liberty ship could cross the Atlantic in approximately 2 weeks, spend 3 days loading or unloading at each end, and make the round trip in 5 weeks. With proper maintenance, a Liberty ship could make 10 transatlantic crossings per year, delivering 100,000 tons of cargo annually. The Germans tried everything to counter the tide. U-boat production reached maximum capacity, with new Type 7 and Type 9 submarines being commissioned faster than ever before. Acoustic torpedoes were developed to counter destroyer escorts. Schnorkel breathing systems allowed submarines to remain submerged longer. New tactics, wolfpack formations, concentrated night surface attacks, everything the Kriegsmarine could devise. Nothing worked. For every U-boat kill, another Liberty ship was already sliding down the ways. The production rate was almost incomprehensible. In 1943 alone, American shipyards delivered 2,244 Liberty ships, each one capable of carrying 10,000 tons of cargo. That was 22 million tons of new shipping capacity added in a single year, more than the total pre-war British merchant fleet. Oberbootsman Hans Gwenter, a U-boat watch officer who survived the war, later described the psychological impact. In 1942, we felt like hunters. By 1943, we felt like we were drowning in targets. The convoys just kept getting larger. Where we'd once see 30 ships, now there were 60, 80, sometimes over 100. Vessels. We'd sink 3, 4, 5 ships in an attack and the convoy would barely notice. There were always more. The worst part was learning that every ship we sank was replaced before it reached the bottom. Our intelligence officers showed us production figures. We thought they were Allied propaganda. No nation could build that fast. But after a while, you couldn't deny the evidence. The ocean was filling with ships faster than we could empty it. The Battle of the Atlantic's turning point came in May 1943. In a single month, Allied forces sank 41 U-boats while losing 50 merchant ships. But those 50 ships represented 264,000 tons of cargo capacity. In that same month, American shipyards delivered 140 Liberty ships, representing 1.5 million tons of new capacity. The replacement rate was 6 to 1. For every ship sunk, 6 more launched. Admiral Dönitz, confronting the impossible mathematics, temporarily withdrew U-boats from the North Atlantic. It was a tacit admission of defeat. The U-boat war couldn't be won by sinking ships when the enemy built them faster than they could be destroyed. The Liberty ships proved their worth in ways beyond simple cargo capacity. When the SS Stephen Hopkins, a Liberty ship armed with a single 4-inch gun and two 37mm cannon, encountered the German commerce raider Stier and her escort in the South Atlantic, in September 1942, conventional wisdom said the American freighter should surrender immediately. The Stier mounted 6 5.9-inch guns, far outgunning the merchantman. Instead, the Hopkins fought. For 20 minutes, the Liberty ship and the German raider exchanged fire at point-blank range. The Hopkins' obsolete guns, manned by Naval Armed Guard gunners and volunteer merchant crew, scored hit after hit on the Stier. Both ships were eventually abandoned, the Hopkins sinking after catastrophic damage, the Stier so badly holed she had to be scuttled. The engagement was tactically a draw. Both ships lost, but strategically it was a revelation. A supposedly disposable cargo ship, armed with weapons from the previous war, had fought a purpose-built commerce raider to mutual destruction. The Hopkins crew, including civilians with no combat training, had fought with a ferocity that shocked the Germans. More importantly, the Hopkins was replaced within 2 weeks. The Stier represented years of construction and couldn't be replaced at all. That trade ratio, 1 disposable American freighter for 1 irreplaceable German warship, was acceptable to American planners. It was devastating to German naval command. The Liberty ship's flexibility became apparent in military operations beyond cargo hauling. Some were converted to troop transports, carrying up to 550 soldiers in cramped but functional accommodations. Others became hospital ships, their cargo holds transformed into wards that could accommodate 200 patients. Some were converted to aircraft transports, carrying disassembled fighters and bombers to forward bases. Others became floating repair ships, tankers, colliers, even floating barracks. The SS John Harvey became infamous as a chemical weapons carrier, sunk at Bari, Italy in December 1943, while loaded with mustard gas shells. The resulting chemical release killed approximately 100 Allied personnel and remains one of the war's most tragic friendly fire incidents. But even this disaster revealed the Liberty ship's versatility. The Germans had no equivalent vessels capable of such rapid conversion to specialized roles. Some Liberty ships were modified into Q ships, heavily armed commerce raiders disguised as normal freighters. The SS Daniel Boone was converted to carry 2 5-inch guns, 8 20 mm anti-aircraft guns, and depth charges, becoming a floating arsenal capable of defending entire convoys. The SS Stephen Hopkins conversion came too late to save her, but later, Q-ship conversions destroyed several U-boats in surface engagements. The most unusual modification was the flight deck cruiser conversion. 8 Liberty ships were fitted with 450-foot flight decks and converted to aircraft ferries capable of launching light aircraft. The SS Adabel Lykes delivered marine fighters to Guadalcanal, the aircraft flying off her deck directly into combat. The concept proved impractical for mass production, but demonstrated the fundamental adaptability of the design. By 1944, Liberty ships had become so ubiquitous that their designation as emergency vessels seemed obsolete. They were the standard American cargo ship, present in every theatre, carrying every type of cargo, participating in every operation. D-Day alone involved 445 Liberty ships carrying the invasion's logistics. Operation Dragoon in southern France employed another 200. The Pacific Island hopping campaign depended on Liberty ships for every amphibious operation. The vessels often deliberately beached to allow direct unloading onto invasion beaches. The SS Richard Henry Dana was beached at Saipan and converted to a floating pier, her cargo hold serving as temporary storage for ammunition and supplies. The SS Nathaniel Howe was sunk deliberately to create a breakwater at Normandy. Dozens of Liberty ships were sacrificed as block ships, floating warehouses and improvised infrastructure. They were expendable in ways purpose-built vessels never could be, their low cost and rapid replacement making them militarily disposable. The German Naval Command finally acknowledged the Liberty ship's strategic impact in a February 1944 assessment. The document, captured after the war, represented a complete reversal of earlier contempt. The American Emergency Cargo Vessel Program represents the decisive factor in the Battle of the Atlantic. The technical quality of individual ships is irrelevant when production occurs at rates that make destruction impossible. The Kriegsmarine cannot sink ships faster than American yards build them. The war of attrition is lost. The assessment noted that Liberty ship production had reached a point where the United States was building more cargo capacity monthly than Germany possessed in her entire remaining merchant fleet. The mathematics were brutal. Germany started the war with approximately 4 million tons of merchant shipping. By early 1944, she retained less than 800,000 tons. The United States was adding 2 million tons of new shipping capacity every month. More significantly, the Liberty ships were enabling Allied operations that would have been impossible with conventional cargo fleets. The massive build-up in Britain prior to D-Day required transporting 2 million tons of supplies monthly across the Atlantic. No conventional cargo fleet could have sustained that tempo, but with Liberty ships being produced at a rate of 140 per month, the surge capacity existed to meet any demand. The economic implications were equally devastating to Germany. Each Liberty ship cost approximately $2 million to build. Each U-boat cost approximately $4 million. The Americans were producing 3 ships for the cost of 1 U-boat. And the U-boat had to sink at least 3 ships to break even economically. The arithmetic of destruction favoured the Americans overwhelmingly. Worse for Germany, the Liberty ships were sustainable. The raw materials for a Liberty ship, 7,000 tons of steel, came from mills in Indiana, Pennsylvania and Ohio that were producing at maximum capacity with no resource constraints. The engines came from manufacturers with unlimited access to precision machinery and skilled workers. The welders, electricians and pipe fitters came from a labour pool of 130 million Americans, many of whom had never worked in industry before the war. U-boat construction, by contrast, was constrained by every resource imaginable. Specialised steel alloys required for pressure hulls, optical glass for periscopes, precision bearings for torpedoes, diesel fuel for operations, training facilities for crews. Every U-boat represented thousands of man-hours of skilled labour that Germany couldn't spare. Every U-boat sunk took an irreplaceable crew of 50 trained submariners to the bottom. By mid-1944, the production differential had created an absurd situation. Allied shipping tonnage was increasing despite continued U-boat attacks. For the first time in the war, more ships were being built than sunk. The Allies weren't just winning the Battle of the Atlantic, they were drowning the Kriegsmarine in a tsunami of steel. The psychological impact on U-boat crews was devastating. Veterans who had hunted confidently in 1942 spoke of the sea filling with targets beyond their capacity to destroy. The convoys grew larger, 100 ships, or 150 ships, escorted by dozens of destroyers and corvettes, covered by long-range aircraft. Attacking meant certain detection, probable depth charging, likely death. Oberleutnant José Herbert Werner, who commanded U-230 and survived the war, wrote in his memoirs about hunting convoys in late 1944. "We'd track a convoy for days, waiting for an opportunity to attack. Finally, we'd manoeuvre into position and periscope depth and you'd see them. Rows of identical boxy freighters stretching to the horizon. You'd sink 1, maybe 2 if you were lucky and bold. The convoy would barely notice. They'd keep steaming, and reinforcements would join from Britain or America. It was like trying to empty the ocean with a bucket." The worst moment came when you realised the ships you were attacking had been built more recently than your submarine. We were in a boat commissioned in 1943, attacking freighters that had been launched in 1944. They were replacing losses faster than we could create them. We were obsolete, hunting targets that existed in unlimited supply. The final Liberty ship production numbers represented industrial might that no nation had ever achieved. From 1941 to 1945, American shipyards delivered 2,110 Liberty ships. The total cost was approximately $5.6 billion, or about $2 million per ship. The combined cargo capacity was 29.7 million deadweight tons, more than the entire world merchant fleet in 1939. The construction consumed 18 billion pounds of steel, enough to build 90,000 Sherman tanks. The engines represented 2.7 billion horsepower hours of manufacturing capacity. The welding alone totaled over 500 million linear feet, enough to circle the Earth 20 times. The workforce at peak employment numbered over 650,000 workers across 18 shipyards. The ships carried 75% of all cargo shipped overseas during the war. They transported 2.4 billion tons of cargo total, including 7 million tanks and vehicles, 140,000 aircraft, 77 million tons of ammunition, and enough food to feed every Allied soldier for the entire war. Without Liberty ships, the Allied victory would have been impossible. The casualties were significant but sustainable. Of the 2,010 Liberty ships built, 200 were lost to enemy action, 31 to marine accidents, and 16 to other causes. That's a loss rate of 9%, high by peacetime standards, catastrophic by any measure except wartime necessity. But for every ship lost, 10 more were launching. The mathematics of attrition favoured overwhelming numbers over individual survivability. The human cost was measured differently. Approximately 5,000 American merchant mariners died aboard Liberty ships, the highest casualty rate of any service branch proportionally. The men who crewed these vessels had no military protection, no status as combatants if captured, and faced death from U-boats, aircraft, mines and storms with nothing but their courage and a 4-inch deck gun for defence. Yet they kept sailing. Through torpedo attacks, through Atlantic storms that broke ships in half, through Arctic convoys where survival time in the water was measured in minutes. The Liberty ship crews were civilians, many in their 40s and 50s, deemed too old for military service. They earned their pay, certainly. Merchant seamen wages were good by wartime standards, but they also earned something more permanent. They earned the knowledge that without their willingness to climb aboard those ungainly steel boxes and sail into submarine-infested waters, the war would have been lost. After the war, the Liberty ship fleet faced an uncertain future. They'd been built for emergency, designed to last 5 years at most. The assumption was that most would be sunk or scrapped by 1950. Instead, they became the backbone of post-war merchant fleets worldwide. Their simplicity, the same characteristic that made them objects of derision in 1942, made them ideal for rapid post-war commercial conversion. Hundreds were sold to private shipping companies. Others were leased or given to Allied nations rebuilding their merchant fleets. Some were converted to bulk carriers, others to tankers. The SS Jeremiah O'Brien became a Liberty Ship Museum ship, preserved in San Francisco as the only Liberty still in operating condition. The SS John W. Brown, preserved in Baltimore, occasionally steams, the only other operational survivor. Many served decades beyond their designed lifespan. The Greek shipping industry, devastated by war, bought Liberty ships by the dozen and operated them profitably into the 1960s. Some soldiered on into the 1970s, rust-streaked veterans of 30 years' service, still hauling cargo in routes their designers never imagined. The last active Liberty ship, converted to a bulk carrier, was finally scrapped in 2008, 65 years after her launch. In 1960, at a NATO conference on naval logistics, Admiral Otto Kretschmer, Germany's most successful U-boat ace with 47 ships sunk, was asked about the Battle of the Atlantic. His response captured the fundamental reality that Germany had faced. We could sink ships. We were very good at sinking ships. We developed tactics, technology, everything we could think of to sink more ships faster, and we did. We sent millions of tons of Allied shipping to the bottom. But it didn't matter. The Americans could build ships faster than we could sink them. That was always true, but we didn't believe it until too late. We thought there had to be a limit, some maximum rate of production that would constrain them. There was no limit. They just kept building faster and faster until the ocean was filled with their ships. The Liberty ship won the Battle of the Atlantic not through any individual quality, but through sheer overwhelming numbers. They weren't better ships than ours. They weren't better than the British ships. They were just everywhere, unlimited, unstoppable. You could sink 100 and another 200 would appear. That's not naval warfare as we understood it. That's industrial warfare, and Germany never had a chance against American industry. The Liberty ship's legacy extends beyond the ships themselves. They represented the apotheosis of American industrial might, proof that quantity had its own quality when produced at sufficient scale. They demonstrated that complex products could be manufactured by unskilled workers if the production process was sufficiently refined. They showed that wartime necessity could override peacetime perfectionism and produce results that exceeded expert predictions. Most importantly, they represented a fundamental shift in military thinking. Wars wouldn't be won by individual superiority, but by logistical supremacy. The side that could sustain continuous operations, replace losses instantly, and field overwhelming numbers would prevail regardless of tactical brilliance or technological sophistication. The Germans had looked at the first Liberty ships and seen targets, ugly, poorly designed vessels that would sink themselves if U-boats didn't get them first. They'd laughed at American industrial naivety, at workers who didn't know proper shipbuilding, at welded hulls that real naval architects knew would fail. They stopped laughing when the Liberty ships kept coming, when every sinking was replaced by 3 new launches, when the Atlantic filled with boxy grey freighters in numbers that made destruction impossible, when their best U-boat aces were dying in boats that couldn't be replaced while American shipyards launched another Liberty ship every 8 hours. By 1945, the Kriegsmarine had been swept from the seas. The U-boat threat, so dominant in 1942, had been reduced to scattered attacks by increasingly desperate crews in obsolete boats. The Liberty ships, those floating shoeboxes that German admirals had dismissed as useless, had carried the armies that liberated Europe, the supplies that sustained them, and the weapons that destroyed the Third Reich. German admirals thought the Liberty ships were useless, until 2,210 of them filled the seas and buried the Kriegsmarine under an avalanche of American steel. The sheer scale of Liberty ship operations created problems that no one had anticipated. By late 1944, American ports were experiencing a crisis not of shortage, but of overwhelming abundance. Liberty ships arrived faster than they could be unloaded. At the port of New York, vessels waited up to 3 weeks for berth space. In Philadelphia, the Delaware River resembled a parking lot of grey-hulled freighters stretching for miles. The bottleneck wasn't production or transportation, it was the physical impossibility of processing the avalanche of cargo arriving daily. The solution was characteristically American. If existing ports couldn't handle the volume, build new ones. The Port of Portland, Maine expanded its capacity 5-fold in 18 months. Los Angeles constructed entirely new dock facilities in Long Beach. The Port of Houston, barely relevant to ocean-going commerce before the war, became a major shipping hub. But even this wasn't enough. The real answer came in the form of something unprecedented: portable ports. The Mulberry harbours constructed for the Normandy invasion were the most famous example, but they were preceded by dozens of smaller installations throughout the Pacific. At Ulithi Atoll in the Caroline Islands, the Navy created a floating logistics base from scratch. Liberty ships were moored in rows, connected by pontoon causeways, creating instant piers in a lagoon that had no port facilities whatsoever. The SS Samuel L. Cobb was deliberately grounded on a reef at Iwo Jima, her cargo holds converted to ammunition storage, her deck becoming a helicopter landing pad. The SS Francis Scott Key served as a floating hospital at Okinawa, moored offshore with her holds transformed into surgical wards. The SS Benjamin Conti became a floating power plant at Leyte, her engine providing electricity for shore installations. Liberty ships had become modular components of military infrastructure, repurposed faster than traditional military planners could process requisition forms. The Pacific War revealed characteristics of Liberty ships that Atlantic operations had only hinted at. The vast distances involved made their cargo capacity even more critical. A Liberty ship departing San Francisco for Manila carried enough supplies to sustain an entire infantry regiment for 3 months. The voyage took 30 days, covered 8,000 miles, and consumed 800 tons of fuel, but that single ship delivered 10,000 tons of cargo, the equivalent of 200 railroad cars or 500 trucks. The Japanese had no answer to this logistic superiority. Their merchant fleet, never large by Western standards, had been decimated by American submarines. By 1944, Japan had less than 2 million tons of merchant shipping remaining, barely enough to sustain domestic transportation between the home islands. They couldn't reinforce isolated garrisons, couldn't evacuate troops from bypassed islands, couldn't even maintain supply lines to their own conquered territories. Captain Tamichi Hara, commanding the Japanese destroyer Shigure, wrote in his war diary about encountering an American supply convoy off the Philippines in October 1944. We observed from a distance. I counted 73 cargo ships, all identical, all heavily loaded. The escorts outnumbered our entire destroyer squadron. We couldn't attack. We couldn't even report their position safely, because their radar would detect our radio transmission. We could only watch as this armada of supply ships steamed past, carrying more cargo than our entire merchant fleet could transport in a month. What defeated us wasn't American fighting spirit or technological superiority. It was this endless river of supply ships. Every battle we fought, the Americans had more ammunition, more food, more fuel, more everything. We were rationing bullets while they fired artillery barrages that lasted hours. Their soldiers had 3 meals a day while ours starved. And behind it all were these ugly cargo ships, thousands of them, bringing unlimited supplies from a nation that seemed to possess unlimited everything. The Liberty ships enabled a style of warfare that would have been impossible with conventional logistics. The island-hopping campaign in the Pacific required establishing new supply bases every few months. Each invasion needed stockpiles of ammunition, food, fuel, construction equipment, vehicles, and every other material of modern warfare. Liberty ships made it possible to establish these logistics bases faster than the Japanese could respond. At Saipan, Liberty ships began arriving before the fighting ended, anchoring offshore and unloading directly onto beaches that were still under occasional artillery fire. The SS Juan de Fuca was struck by a Japanese shore battery while unloading ammunition, her crew abandoning ship as fires reached the cargo holds. The ship should have exploded. Instead, a damage control party from a nearby destroyer boarded her, flooded the cargo holds with seawater, and saved the vessel. She was repaired and back in service within 6 weeks. The SS Thomas Nelson was torpedoed by a Japanese submarine off Guadalcanal, the torpedo punching a 30-foot hole in her side below the waterline. The explosion killed 8 crew members and flooded 2 cargo holds. The ship should have sunk within minutes. Instead, her crew sealed the damaged compartments, her engine kept running, and she steamed 1,200 miles to Noumea under her own power, arriving 5 days later with a 15-degree list but still afloat. The cargo in the undamaged holds was unloaded, the ship was patched, and she returned to service. These survival stories became legendary among merchant seamen. The Liberty ship's reputation evolved from death trap to survivor. Yes, they were crude. Yes, they were uncomfortable. Navy inspectors noted that crew quarters aboard Liberty ships were inferior to those on prison ships from the previous century. Yes, they were slow. Their 11-knot maximum speed meant crossing the Pacific took weeks longer than faster vessels. But they were tough in ways that elegant ships weren't. They absorbed damage that should have sunk them and kept sailing. The explanation was partly structural and partly philosophical. The massive redundancy built into every system meant single-point failures rarely sank the ship. The engine, a simple triple-expansion reciprocating steam design, could run on contaminated fuel that would kill a turbine. The boilers, obsolete by modern standards, were nearly indestructible and could be repaired by any competent machinist. The electrical system was so simple that crew members with no electrical training could troubleshoot problems using nothing but a multimeter and common sense. But the deeper reason was design philosophy. Liberty ships were built to be repaired by unskilled labour using basic tools. Every major component could be accessed without specialised equipment. Damaged plates could be cut out and replaced by any welder. Engine parts were standardised and interchangeable. There were no proprietary systems, no specialised components that required factory-trained technicians. A Liberty ship could be repaired in a forward area maintenance facility using nothing but standard welding equipment, cutting torches, and determination. This maintainability proved decisive in the Pacific, where purpose-built vessels often required return to major shipyards for repairs. Liberty ships could be patched together in improvised facilities and returned to service in days. The SS Stephen F. Austin was hit by a kamikaze off Okinawa, the aircraft's engine punching through the deck and into a cargo hold. The ship made it to an anchorage where Navy repair crews welded steel plates over the hull, reinforced the damaged deck beams with timber, and declared her seaworthy. She sailed with a cargo of ammunition 2 days later. The kamikaze campaign of 1945 revealed another Liberty ship characteristic. They were difficult to sink even with direct hits. The SS Hobbs Victory, technically a Victory ship but built using Liberty ship principles, was hit by 3 kamikazes in succession off Okinawa. All 3 aircraft penetrated the deck and exploded in cargo holds. Fires raged throughout the ship. The crew abandoned ship, certain she would explode or sink. She did neither. Damage control parties reboarded her, extinguished the fires, and she was towed to port. After repairs, she returned to service and operated commercially until 1966. The reason was simple construction. There wasn't much to destroy. No complex fire control systems, no delicate radar equipment, no vulnerable turbine machinery. Just steel plates, simple steam systems, and cargo holds. The holds themselves were largely empty space. A bomb or kamikaze could explode inside, causing spectacular damage, but there was nothing vital to destroy. Unless the hit ruptured the hull below the waterline or destroyed the engine, the ship would likely survive. German naval architects examining captured Liberty ships after the war were appalled by what they considered crude construction. Weld beads that would have been rejected in German yards, plate alignment that was merely adequate rather than precise, systems that were functional but inelegant. But they grudgingly acknowledged that this crude simplicity was itself a form of military effectiveness. The ships were so simple, they were almost impossible to critically damage. In contrast, German merchant vessels built to higher peacetime standards proved surprisingly fragile under combat conditions. Complex steam systems were vulnerable to shock damage. Precision machinery required skilled maintenance. Sophisticated electrical systems failed catastrophically when damaged. The Germans had built ships for efficiency and performance. The Americans had built ships for survival and mass production. By early 1945, Liberty ships had become so commonplace that their presence was simply assumed in military planning. An amphibious operation required 50 Liberty ships as baseline logistics. An overseas base needed 20 Liberty ships as floating storage. A supply route needed Liberty ships in continuous shuttle, one arriving as another departed. The entire American military machine had become dependent on the endless flow of those ungainly freighters. The final statistics of the ship that Germany had dismissed as useless were staggering beyond comprehension. The 2,710 Liberty ships built during the war represented 1/3 of all merchant ships constructed by all nations combined during the entire war. Their combined cargo capacity exceeded the total merchant fleet of Germany, Italy, and Japan combined at the start of the war. They carried enough cargo to fill a freight train that would circle the Earth 30 times. The ammunition alone transported by Liberty ships totaled 77 million tons. That's 2.5 billion artillery shells, or 100 billion rifle rounds, or enough explosives to create a crater visible from space. The food transported would have filled every grocery store in America. The fuel would have run every automobile in the United States for 2 years. The vehicles transported 7 million tanks, trucks, and jeeps would have stretched bumper to bumper from New York to Los Angeles and back 3 times. But beyond the statistics was the strategic reality. Liberty ships had broken the back of German naval power through sheer overwhelming abundance. The Kriegsmarine had entered the war with sophisticated strategy, well-trained crews, and technological advantages. They lost to a nation that simply built more ships than could possibly be sunk. Admiral Dönitz, in his post-war memoirs, acknowledged the fundamental impossibility of defeating the Liberty ship program. We calculated that we needed to sink 700,000 tons monthly to win the Battle of the Atlantic. At our peak, we achieved this briefly in 1942, but the Americans were building 2 million tons monthly by 1943. The mathematics were impossible. We would have needed to triple our U-boat fleet while the Americans reduced their construction by 2/3. Neither was possible. The Liberty ship wasn't a better ship than anything we built. It was a worse ship by every traditional measure. But it was better at the one thing that mattered, existing in overwhelming numbers. By 1944, we weren't fighting the American Navy or the British Navy. We were fighting American industry, and you cannot sink a factory with a torpedo. The human stories behind the statistics reveal the true cost and achievement of the Liberty ship program. The crews who sailed them were civilians, many of them middle-aged men deemed unfit for military service, boys too young to enlist, and an increasing number of women. They had no boot camp, no military discipline, no promise of veteran benefits. They signed on for wages, certainly, but they also sailed into combat zones knowing that merchant mariners had the highest casualty rate of any service. The armed guard crews, Navy gunners assigned to man the defensive weapons, averaged 19 years old. They went through basic training and gunnery school, then were assigned to merchant ships where they were technically under the command of civilian masters. The relationship was often tense. The merchant crew wanted to evade danger. The armed guard wanted to fight. Compromises were reached through mutual respect and shared danger. Ensign Kenneth Wilder, commanding the armed guard detachment aboard the SS John Bascom, wrote in his diary about the relationship between Navy and merchant crew. The merchant captain is 54, sailed the seas for 35 years, knows more about ships than I'll ever learn. His crew are civilians, some of them older than my father. My gunners are teenagers. Most of them never saw the ocean before joining the Navy. On paper, we're all on the same ship but serving different services. In reality, we're all just trying to survive and get the cargo delivered. After 3 convoys, I stopped seeing civilians and navy. We're all merchant mariners. When the general quarters alarm sounds, the civilian crew runs to their abandoned ship stations while my gunners run to the guns. Both groups are terrified. Both groups do their jobs. The chief engineer, who's 58 and should be retired, keeps that engine running through attacks that would justify shutting down. My loader, who's 17 and should be in high school, keeps feeding ammunition to a gun that's firing at aircraft he can barely see. We're all just doing impossible things because the alternative is worse. The SS Stephen Hopkins' battle with the Steer had established that merchant crews would fight even when outgunned. Subsequent actions confirmed this wasn't an anomaly. The SS Jean Nicolet fought off a German surface raider in the South Atlantic. The SS Samuel Parker exchanged fire with a Japanese cruiser off New Guinea. The SS Richard Montgomery engaged German aircraft over the English Channel. In each case, civilian crews and teenage Navy gunners fought with a determination that military planners hadn't anticipated. The most decorated merchant ship of the war was the SS Jeremiah O'Brien, which participated in the D-Day invasion and survived multiple air attacks, submarine encounters, and storm damage. Her crew received no medals. There were no decorations for merchant mariners during the war, but they compiled a record of 5 years' continuous service that exceeded most naval vessels. She made 11 transatlantic crossings, delivered over 100,000 tons of cargo, sailed through minefields, survived near-miss torpedo attacks, and outlasted the war to become a museum ship still capable of getting underway. The preservation of the O'Brien and the John W. Brown represented something beyond historical conservation. They were the last operational examples of the weapon system that had won the Battle of the Atlantic. Not battleships or carriers or submarines, but ungainly cargo ships that had simply overwhelmed the enemy through mass production. In 1994, the Jeremiah O'Brien steamed across the Atlantic to participate in the 50th anniversary of D-Day, the first Liberty, ship to cross the Atlantic under her own power in decades. She was joined by the John W. Brown. The 2 ships, surrounded by modern naval vessels, represented a style of maritime warfare that had vanished. They were slow, smoke-belching relics of an age when wars were won by logistics rather than precision weapons. Veterans of both sides gathered to watch the Liberty ships steam past. German U-boat veterans saluted. Allied merchant mariners wept. Everyone present understood they were witnessing the last voyage of the weapons that had decided the war. The Liberty ships were crude, uncomfortable, obsolete before they were launched, but they had buried the Kriegsmarine under a tidal wave of steel and won the Battle of the Atlantic through sheer overwhelming production. The economic legacy of Liberty ship production extended far beyond the war. The shipyards built to construct them became centres of post-war industry. Kaiser's Richmond shipyard became a major automobile manufacturing facility. The New England Shipbuilding Corporation in South Portland became Bath Iron Works, still building naval vessels today. The training programs that taught welding to housewives created a generation of skilled workers who rebuilt American industry in the 1950s. The techniques developed for Liberty ship production influenced every subsequent mass production program. Modular construction, prefabrication, assembly line techniques applied to complex products all became standard industrial practice. The Liberty ship proved that traditional craft production could be transformed into industrial processes without sacrificing quality, a lesson that transformed post-war manufacturing. More profoundly, the Liberty ship changed military thinking about logistics. Before World War II, military planners focused on fighting forces, divisions, fleets, air wings. Logistics was an afterthought, something handled by supply officers but not considered strategically decisive. The Liberty ship proved that logistics wasn't supporting the war effort, it was the war effort. The side with superior logistics would win regardless of tactical outcomes. This lesson shaped American military doctrine for the next 80 years. Every American military operation since 1945 has begun with logistics analysis. How many tons of supplies per day? How many ships or aircraft to deliver them? What happens if we lose X% to enemy action? The Liberty ship taught American planners that overwhelming logistic superiority was the foundation of military success. The Soviet Union, observing American production during the war, attempted to replicate the model with their post-war merchant fleet. They built thousands of standard cargo ships using mass production techniques. But they never achieved American efficiency. The Liberty Ship program required not just factories but an entire industrial ecosystem. Steel mills, engine manufacturers, component suppliers, all operating at maximum efficiency. The Soviets could copy the ships but couldn't replicate the system that produced them. China, emerging as an industrial power in the late 20th century, studied the Liberty Ship program extensively. Modern Chinese shipbuilding, with its emphasis on standardized designs and massive production volumes, owes much to lessons learned from American World War II production. The ability to build dozens of identical ships simultaneously, to create supply chains that feed multiple shipyards, to train workers rapidly for specialized tasks, all derived from techniques pioneered by Kaiser and his contemporaries. The Liberty Ship's cultural impact was equally significant. They represented proof that American industrial might could overcome any challenge. Movies, books, and documentaries celebrated the ships and their crews. Action in the North Atlantic starring Humphrey Bogart dramatized the merchant marine experience. The story of the Liberty Ship became required viewing in industrial management courses. The ships became symbols of American resourcefulness, the ability to solve problems through brute force application of production capacity. But there was a darker legacy. The Liberty Ship program succeeded partly through exploitation. Workers in Kaiser's shipyards worked 6-day weeks, often in dangerous conditions. Safety standards were relaxed in the name of production speed. African Americans and women were hired in unprecedented numbers, but often faced discrimination and were paid less than white male workers for identical work. The program's success came at human cost that was often overlooked in celebrations of industrial achievement. The environmental impact was never calculated. The ships consumed resources at staggering rates. The steel production alone required coal, iron ore, and limestone in quantities that scarred landscapes. The welding consumed enough electricity to power a medium-sized city. The paint used enough toxic materials to qualify as environmental disaster by modern standards. The Liberty Ship program worked because nobody questioned the environmental cost. It was wartime. Victory justified everything. Post-war, many Liberty ships were sold to shipping companies that operated them with minimal maintenance and maximum profit. Ships that had been built to last 5 years were run for 20 or 30 years. Safety standards declined. Crews were reduced to minimum manning levels. Accidents increased. The SS Marine Electric sank off Virginia in 1983 with a loss of 31 lives, a World War II-era freighter that should have been scrapped decades earlier, but was still hauling cargo in dangerous winter conditions. These tragedies revealed the Liberty Ship's true nature. They were emergency weapons, built for wartime necessity, not peacetime safety. Keeping them in service beyond their designed lifespan was profitable for owners, but dangerous for crews. The ships that had saved the free world during the war became maritime hazards in peace. By the 1980s, most Liberty ships had been scrapped. A few survived as museum ships. Dozens were deliberately sunk as artificial reefs. Some were beached and abandoned in third-world ports, slowly rusting into unrecognizable hulks. The great fleet that had numbered 2,710 ships dwindled to a handful of survivors, most of them incapable of getting underway. The final operational Liberty Ship voyage occurred in 1994, when the Jeremiah O'Brien crossed the Atlantic. It was a memorial voyage, not a practical one. The ship burned fuel at rates that would bankrupt any commercial operator. Her 11-knot speed made her an obstacle to modern shipping. Her cargo capacity, impressive in 1943, was dwarfed by modern container ships carrying 5 times the load at twice the speed. The Liberty Ship had been made obsolete not by better designs but by entirely different concepts of maritime commerce. Yet the O'Brien's 1994 voyage was profoundly moving to those who witnessed it. This was the ship that had won the war. Not elegant, not sophisticated, not even particularly good at being a ship, but present in overwhelming numbers when it mattered most. The last steam whistle of the last operational Liberty ship as she arrived in Normandy for the D-Day anniversary sounded like an echo from a different world, when wars were won by crude weapons produced in massive quantities, rather than sophisticated systems deployed in limited numbers. In 2004, on the 60th anniversary of D-Day, the few surviving Liberty ship veterans gathered in Portsmouth, England. Most were in their 80s. They'd sailed as teenagers on ships they'd expected to sink. Many had survived torpedoing, Some had been on ships that broke in half from structural failure. All had watched friends die in the cold waters of the Atlantic or Pacific. Admiral Sir John Fieldhouse, former First Sea Lord of the British Royal Navy, addressed the veterans. The Liberty ship was not the best ship ever built, but it was the most important ship ever built. It represented the moment when warfare shifted from limited conflict between professional forces to total industrial warfare. The Liberty ship proved that the nation with superior production would defeat the nation with superior tactics. That lesson changed military history. You men who sailed these ships, you weren't the best sailors. The Royal Navy had better training. The German Navy had more experience. But you had something more important. You had the industrial might of America behind you. For every ship that was sunk, 3 more launched. That's not seamanship. That's not courage, though you had both. That's industrial supremacy transforming war itself. The Germans laughed at your ships in 1942. They stopped laughing when they realized you were building ships faster than they could sink them. That's when they knew the war was lost. Not at Stalingrad, not at Midway, not at any battle. They lost the war in Kaiser's shipyards, where housewives who'd never seen a ship were building them faster than combat-trained U-boat crews could destroy them. The last Liberty ship veteran died in 2017 at age 94. He'd been 18 when he sailed on the SS William Clark in 1943. He survived 2 torpedo attacks, a collision, and a fire that should have destroyed the ship. In his final interview, he was asked what he remembered most about serving on a Liberty ship. "The sound," he said. "That triple expansion engine made a sound like nothing else, a rhythmic thumping that you felt in your bones. When you were below decks, it was deafening. But it meant the ship was alive, moving, taking us and our cargo where it needed to go. I heard that sound in my sleep for 60 years after the war. It's the sound of survival, the sound of winning, the sound of a crude, ugly ship that did exactly what it was built to do: deliver the goods and bring us home." The Liberty ship program cost $5.6 billion, approximately $80 billion in modern currency, that purchased 2,110 ships, 29.7 million deadweight tons of cargo capacity, and victory in the Battle of the Atlantic. The return on investment was incalculable. The ships carried the armies that liberated Europe, the supplies that sustained them, and the weapons that destroyed fascism. German admirals had thought they were useless, ugly, crude, disposable vessels that would sink themselves if the Kriegsmarine didn't sink them first. They'd laughed at American industrial naivety, at the concept that workers with no experience could build ocean-going vessels, at the idea that quantity could substitute for quality. They stopped laughing when 2,110 Liberty ships filled the seas, when every U-boat kill was replaced before the wreckage settled to the bottom, when the Atlantic became an American highway lined with grey-hulled freighters carrying unlimited supplies to armies that never ran out of ammunition, never ran short of fuel, never lacked for food. The Liberty ship won the Battle of the Atlantic not through any individual excellence, but through overwhelming numerical superiority sustained by industrial capacity that no enemy could match. They were crude, uncomfortable, and obsolete before launching, but there were 2,110 of them, and that made all the difference.